I'll get started in just a little bit. Feel free to ask away on Discord or on YouTube or on Zoom. I have all the chats up. Cool. It's 5:35, so I think we can get started. Okay, welcome to CIS 140NA, Network Analysis using Wireshark. My name is Irvin Lemus. I am the professor for cybersecurity at Cabrillo College, and we'll be teaching this course. This course focus is using Wireshark extensively. We will spend quite a lot of time using Wireshark and all the tools that are within it. You'll be able to use Wireshark in things like troubleshooting, in network security, and network forensics, along with preparing for the WCNA certification exam. There are a number of links that you should be familiar with. All Cabrillo College students, you should use this link to log into Canvas. That is where your grades will exist. This class is open to anyone outside of Cabrillo who just wants to take this class. You can jump to my website and take it for free. Everyone should be on Discord. A big part of your grade is discussion, and our discussions are completely done on Discord. So if you are not on that, please jump on that sooner than later. Failure to be an active member of the community does end up resulting in a letter grade drop. A number of students saw that last semester, so putting out the warning now that you should be active on Discord. If not, you'll see that that low grade later. And lastly, all videos are recorded and posted on YouTube for later viewing. Attendance to class is not mandatory. It's always recommended, but I understand that you have things to do. And I also understand that it's a Wednesday night when this class happens, so I get it. Just remember to watch the recordings and stay caught up with the class. The way this class is structured is very similar to other classes that I teach. There is a lecture section that has all my notes. So if you want to read through my speaking notes, they are all here in the green arrow. Weekly work will appear under lab and review. So if you want to see what you have due every week, it's under lab and review. And speaking of that, all assignments have a due date. For example, Module 1 assignment is due on February 2nd. I understand that life happens, and I will not punish you because life happened and you needed to take care of life and then come back to this course. To that end, the date that I want you to be cognizant of is May 18, 11:59 p.m. You are able to submit any and all assignments with no penalty for late submission until May 18. So you have the entire 16 weeks of the course to go through the content, submit everything, and stay up to date. And again, if you fall behind because life happened, there is no punishment for you. Just get everything turned in before May 18, 11:59 p.m. Once that day strikes, then no work will be accepted afterwards. So you have plenty of grace time should life happen. If you have any questions on the course, on how it works, please feel to ask away on Discord. So I'll make a quick video out of that. And upload it, and then we will proceed with the course. Upload this orientation to YouTube. CIS 140 NA orientation. And we'll put this into a playlist. That way you can watch it later in order. Not made for kids. And make it public as soon as it's ready. Excellent. So for this class, you will need any computer with a browser. You could use Wireshark. You can download and install Wireshark on your computer. It is free and open source. Or you could also use CloudShark, which is basically Wireshark, but through the browser. There is a link in the Discord chat that has all the files you need for the semester, with the exception of one because it was too big. But 99% of all the files mentioned in all the lectures and all the quizzes and assignments are preloaded for you at that link. So you don't even have to download anything. You could do this entire class from the browser. But I leave it up to you to decide whether you want to download all the book supplements, which you are more than welcome to, and install them on Wireshark Locally, which again, you are more than welcome to. So let's hit record. Let's begin with the world of network analysis. Network analysis offers an insight into network communications to identify performance problems, locate security breaches, analyze application behavior, and perform capacity planning. To be a network analyst who can spot the cause of performance problems, evidence of breached hosts, misbehaving applications, or the impending overload of the network, you need these three basic skills. You'll need a solid understanding of TCP/IP communications. You need comfort using Wireshark, CloudShark, or any number of other tools, and familiarity with packet structures and typical packet flows. The first one you should have coming into this class, because this class assumes you have already taken some form of a networking course, whether that is Cisco networking or Network Plus or anything of that nature. You have already taken and have the understanding of TCP/IP communications. This class will focus on the other two. We'll get you comfort with Wireshark, and we'll get you familiarity with the many packet structures and typical packet flows. From a network analyst's perspective, you need to understand the purpose of devices, protocols, and how they interact. Seeing processes in action at the packet level is a fast way to learn the inner workings of your network. Essentially, in this class, you will be looking at networks at a microscopic level. Now, here's your first analysis to look at. The file is http wireshark download-slow.pcapng, which again, you can see in the link in Discord, or you can download the supplements yourself. The typical network analysis session includes several tasks: capturing at the appropriate location, apply filters to focus on traffic of interest, reviewing and identifying anomalies in the traffic. In this trace file, the client makes a TCP connection with wireshark.org and then sends an HTTP GET request asking for the default GET / as shown in packet 10. As shown right here. If everything went well, the HTTP server will respond with a 200 OK, and the page download begins. So a question that you'll need to answer is that what packet does the user request download.html? A walkthrough of a troubleshooting session would be step 1, plan. The who, what, where, when, how, and whys. We'll see the action as close to the source of the complaint. Like if it's an end user, we'll check out their computer. Or if it's a laptop, we'll get as close to whatever device is the source of the complaint. Maybe it's a server. Next, we'll capture traffic. We want to see everything that's happening in order to get the biggest picture. Then we'll analyze, isolating the traffic that's related to the issue. So you notice in the capture phase, we want everything. For analysis, we'll dig down to specific traffic that we're looking at. Then we'll follow that traffic to determine if the first device is at fault. If not, then we'll keep repeating until the issue is resolved. For network forensics, it's pretty similar. Number 1, we'll plan. We'll have proper evidence handling considerations because what we're doing may end up in a court of law, so it has to follow a scientific method. We'll set Wireshark next to the suspect devices to capture in stealth mode to not be intrusive. We'll capture traffic, capturing everything as is, noticing behavior, and then begin analyzing as the traffic is captured. Digging into said behavior to see what's going on and provide some solutions to resolving the issue. For example, if it's a bot or if it's malware. We'll secure the system by isolating that infected host, rectifying the issue, while analyzing other computers to see if they are also infected or showing very similar symptoms. Lastly, we'll document. We'll create a document with all the findings, a way to educate users on the symptoms and how to report, and report to management on future vulnerabilities with this traffic that we found, and also help IT staff to correct the issue for the future. As a network analyst, you have a number of tasks at hand. You'll need to be doing troubleshooting, which is the most common use for Wireshark. There's also security. This can be proactive and reactive. We could do reconnaissance on a network, for example. We can use Wireshark and the network skills that we will cover in this class for optimization, contrasting current performance capabilities, and making adjustments to reach that optimal performance. And application analysis, looking at traffic generated by an application that's connected on our network, such as email or a custom-built program, a web server, all that kind of stuff. The issues with the content we're going to cover in this class. Well, network analysis can be used for malicious tasks. Companies should define specific policies regarding the use of a network analyzer. For example, who can use it, how, and where. For a client, anybody using network analysis should sign a non-disclosure agreement, since what you are capturing is everything on a network. That could be sensitive information, could be PII, could be IP, could be anything. You want to have a secure place to store your captured traffic because, again, you can be capturing a lot of essential information, a lot of sensitive information, since we are listening to everything that's happening on the network. You want to protect your network against unwanted sniffers. You only want any authorized sniffers used by authorized personnel and nothing more. Because again, that could lead to so many legal troubles. For her example, Title I of the Electronics Communication Privacy Act or the USA Patriot Act can come into play when Wireshark is used inappropriately, since it can be used for wiretapping or electronic surveillance. If you don't have the proper permissions to use it, you can land yourself in a lot of legal hot trouble. Yeah, a lot of legal trouble that you don't want. Through this course, you will be faced with the needle in the haystack issue. We're going to go through a number of procedures to overcome this. So please don't feel overwhelmed using this tool. We will make sense of all the facets that this tool has every week as we go through all of the chapters. So a quick recap in your network knowledge, starting with switches who run at layer 2 in the OSI model, forwarding packets based on destination MAC addresses. They don't change the MAC or IP address in the packets. When a packet arrives at a switch, it is checked to ensure it has the correct checksum. If the checksum is bad, that packet is discarded. If the packet is good, the switch looks at the MAC destination, consults the address table to see if it knows which switch port leads to the host using that MAC address. Otherwise, it will forward it out to all ports in hopes of discovering the target when it answers out on the appropriate switch port. Switches forward all broadcast traffic to all ports. If not configured with Internet Group Management Protocol, switches will also broadcast multicast traffic. Routers, working at layer 3, forward traffic based on the destination IP address in the IP header. When a packet arrives to a router, the checksum is validated, Ethernet header containing the MAC address is removed, and the time to live is examined. If the TTL is too low for For example, a value of 1, it is discarded. If it's not too low, the router consults the routing table to determine if the destination IP network is known. If that network, that target network, is directly connected, the router will forward the packet accordingly. Otherwise, it will forward it to the next hop router it learned about when consulting the routing tables. Routers can also contain rules that block or permit packets based on the addressing information or other characteristics. Basic firewalls will also operate at layer 3 like routers, forwarding traffic not blocked by a rule. The firewall prepends a new MAC address header on the packet before forwarding it. Additional packet alteration will take place in the firewall if it supports added features like NAT or proxy capabilities. NAT, or network address translation, alters the IP address in a packet. It's often used to hide the client's private IP address by altering the source and destination IP address of the packet, and tracks the connection relationships in a table to forward traffic properly when a reply is received. Port address translation works very similar, using that same method as NAT for demultiplexing multiple internal connections when using a single outbound address. The address you see on one side of the NAT or PAT won't match to the other side of the device. In order to correlate, you need to look past the IP header to identify matching packets. Regarding proxies, clients connect to the proxy server, and the proxy server makes a separate connection to the target. There are two totally separate connections to examine when troubleshooting proxy communications. Here's another question for you to look at, for the course, looking at VLANs and what each packet tells the network that the VLAN tag exists, what in each packet tells the network that a VLAN exists, and what VLAN is the communication happening on. And now a quick history of Wireshark. Gerald Combs originally released Ethereal in 1997, 1998, and changed it to Wireshark in 2006. It runs on most operating systems. It's really rare to find an OS who doesn't run Wireshark. Stable versions of Wireshark are always denoted by even numbers after the decimal point, and development are always in odd number. Wireshark has used Bugzilla to keep track of any issues with them. It used to be that you needed different libraries like libpcap and winpcap. It's just one library now that Wireshark uses for everything. Wireshark is also able to open a variety of files. You can see the whole list under File Open, and you'll see quite a large drop-down list. It is a very versatile tool. This slide helps you see how Wireshark is built. It has the core engine, or the glue that holds the other blocks together. There are the dissectors, the plugins, and display filters applied to traffic. Dissectors decode the packets to display field contents and interpretive values if those are available. From there, you have everything else like the dump cap engine, any other libraries, and the network itself. Or if you are opening a file that already has packets within it, it gets loaded through the wiretap library and then up to the core engine. Here's Wireshark, version 3.0.5, running on a Linux system. You have a number of things to look at. For example, You have the capture area, the interface lists, where you see what interfaces a Wireshark already sees, along with real-time graphs to display traffic. You have the online help, very useful in looking things up, like the user guide, the wiki, and more. You also have the file area where you can see files that were opened recently, right in between. Here's just a look at Firefox, at Wireshark. Open. We have the title area, all the menu options. We have the main toolbar. We have the display filter. This whole section is the packet list pane, the packet details pane, and the packet bytes pane. The entire bar at the bottom is the status bar, which has the expert info, the trace file annotation, that'd be number 2, the file information column, the packets information column, and the profile. That expert button, the number 1, will have a number of colors to it to denote certain things that Wireshark saw when it opened the file. It becomes very useful for analysis. And we're actually going to spend an entire chapter talking about the expert button and what the colors mean in depth and what rules trigger what. Yeah, the file section has that info, the profile that you'll be using. Some of my graphics are not running on time. When opening the Wireshark menu, you'll have a section for file set. So if you're working with multiple capture files, that let's say you captured over an hour and you made small files to easily digest, you can open it through file set. You can export any files you found in the packet. Like let's say somebody downloaded a picture or downloaded a video, you can reconstruct it and export it from Wireshark. The suspense is killing me. What is this? Be careful with this. You have the edit section where you can do all kinds of things, from finding specific packets to marking them or ignoring, changing the time when let's say we want to create a timeline of events. We can shift the time as needed. We can put packet comments on packets, very useful when doing analysis. The configuration profiles and any main preferences to the current Wireshark profile. In the view, you'll have a number of items, from displaying the time to colorizing conversation. So if you want a specific conversation to have a different color to it, showing packets in new windows, reloading, and name resolution, which is the item that this arrow has been leading us towards. Basic name resolution is at the MAC layer, network layer, and transport layer resolution. By default, the first 3 bytes of the MAC address and port numbers in use are resolved. IP address to host names are not resolved. That item is dangerous because if you need to capture traffic in complete stealth, you don't want to do any name resolution. If you enable name resolution during a capture, that data will show up not only in your trace, but will also show up in the network. So if somebody is trying to be stealthy by capturing traffic and not being shown, and they're doing name resolution, well, they're giving away that they're running something like Wireshark. Yeah, the coloring rules are very useful for profiles. I highly suggest colorizing your conversations, especially when you're digging down trying to find certain information. Then we have items like the Go category, which they're pretty much all self-explanatory. The Capture, which has certain options for the capture interface, or if we're capturing multiple files. Any possible ring buffer options, stop capture options. Like I said, a lot of this we're going to get into depth later. This is more of just a tour of the program itself. We have Analyze. We can do things from showing the display filters, any macros, what do we want to display in columns, any conversation filters, protocols. If something isn't detected well, we can change it with decode as. We can follow certain streams as we want to dive further, like the UDP, TCP, or SSL streams, and also any export information. The display filters one will be key as we get more into the tool. We have statistics, which give us all kinds of information that is useful when we need to make a case, when we need to look at troubleshooting, when we're doing forensics, all that kind of stuff. The statistics section comes into play. A lot of this info is already auto-generated for us. We just have to go and get it. There's also a whole section dedicated to telephony, to everything from VoIP calls to cell phones to all kind of stuff. That is all here that we can get. And again, Wireshark can already understand all that kind of traffic. You just have to provide it, and it will generate all kinds of statistics for you. There's also a section dedicated to all things Bluetooth and wireless traffic. And a couple tools. The About page will give you any capabilities that already exist in Wireshark. And this again is something that we'll explore a little later. For example, we can set a Wireshark to tell us where in the world an IP address is at without having to do more work. That capability will show up here in the About. The last chapter for the day is capturing traffic. A best practice to answer this question, where is the best place to tap the network? A best practice is to place your analyzer as close to the client in question as possible to identify traffic issues from that client's perspective. By capturing at this location, you can measure round trip time and identify packet loss at the point where the client connects to the network. If everyone connecting to a server is complaining, you may still want to capture from a client's perspective. If the problem is packet loss, you can move Wireshark closer to the server until you find a location where packets are being dropped. Because again, at the beginning, we don't know where the problem is. So we want to start from the client and work our way up the network to see where the problem truly exists. We could run Wireshark locally if we have the proper permission and the capability to install and run locally. We could see what the client itself actually sees. We could move up the chain to see what this group in switch A sees. Move up to the router level, or all the way across to the server, trying to find at what point does the problem begin? Where does it exist? Where is it happening? Because it could be a switch, it could be a router, it could be a cable. You know, using Wireshark will help figure out networking issues. So again, you could run Wireshark locally. It's easy to install. There is a portable version that you can get. I wouldn't install Wireshark on a server since servers tend to get more traffic. I would run instead T-Shark because it is lighter and can still do the same job. You could capture traffic on switches since they can control and isolate traffic. And again, on a switch, which is kind of the problem, you can only see broadcast traffic, multicast traffic if it's forwarded, traffic to or from your own hardware address, or traffic from unknown hardware addresses. At this point, if you were bringing in your computer to run Wireshark against client A, you'd have to figure out other ways to do it. You could install a hub into half duplex mode. You could tap into a half or duplex mode traffic. You could span a switch port or install Wireshark locally. Standard hubs can be used to monitor half duplex network traffic by connecting the hub in line between half duplex devices. You definitely should ensure that the hub is a hub, as most manufacturers have really been selling switches and describing them as hubs. A simple way is to have 3 devices connected to the hub with running Wireshark. If Wireshark can see a ping between devices 1 and 2, you know that device is a hub. A more preferred way is to use a test access port on full duplex networks, or a network tap, that's what it's called. Network taps can be used on half or full duplex and to listen to traffic between the client or server and switch or router. Taps are passive devices that they can be placed in line between the devices. Unlike span switch ports, taps forward packets that contain physical layer errors to the monitor port. So you really get to see the big picture off these guys. There are non-aggregating taps that will pass full duplex communications out 2 separate ports. So you'll need a device running Wireshark with 2 NICs to capture both sides. And then use other tools like MergeCap to combine the trace files. You can also use aggregate taps that are full duplex and bidirectional. Traffic can be completely captured by one interface for both sides of the communication. On Canvas, I have this picture along with a link to Amazon where you can buy that tap. I have been using it to great success. So just want to share that with you. If you feel like you want to buy a tap, there's one that I recommend. There are also regenerating taps that are used when you have more than one tool for listening traffic. For example, like if you're listening for Snort, Suricata, Zeek, and whatnot, all together under one roof. Here's an example of a regenerating tap and an aggregating tap. There are also link aggregation taps where you can link more than one monitor. There are also intelligent taps that self-determine where packets to go. These can get way more expensive. You can use a spanned port, or they're also called port mirroring or port snooping. But the switch has to already have that capability built in order for you to use it. Spanning VLANs can be a hit or miss. The device who's listening shouldn't have the VLAN configured. You want to capture as much traffic as possible. If the NIC does not handle well with it, then you might not be able to see all the traffic. Right, because it'll only be visible to drivers as it goes up the chain. And you can see this in VLAN general. You have packet 1, who is transmitting 1,518 bytes on the wire, and it's a VLAN packet with the VLAN ID of 32. Right, when you see the X8100, that tells you, hey, in VLAN information will follow. And there's the VLAN tag. Now, routers isolate traffic based on network addresses. So Wireshark can be placed on one side of the router to display traffic destined to or coming from that network. Looking at the picture below, Wireshark number 1 can see traffic from clients A to C and network 10.2.0.0, whereas Wireshark 2 can only see traffic to and from server B and the local or remote networks. Right, so client number 1 will be able to see these guys and this network, because that traffic will come in and out through this switch. Wireshark number 2 is stuck down here. So it'll only be able to see whatever's coming in and out of server B, since server B and Wireshark are both the only two things connected to the switch. So here's a question: can a Wireshark number 2 see server A, who's right here? The answer is no, again, because server B and Wireshark 2 are connected together, and then here's the uplink out. Wireshark can't see outside of this internal network. Can Wireshark number 2 see 10.1.0.0? Answer to that is no again. Wireless networks. It is recommended to start from the bottom and move up through the protocol stack when analyzing wireless environments. Analyze the strength of the radio frequency signals and look for interference first. Like wired networks, start as close as possible to the complaining user. You want to learn the signal strength, packet loss rate, the wireless retry rate, and round-trip time latency time at the location of the user. Now, Wireshark is unable to identify unmodulated RF energy or interference. For that, you'll need a spectrum analyzer. Once you have determined that the interference is not an issue, then move up to the packet level to examine wireless traffic, such as connection, processes, and authentication. Examine the wireless control and management processes to make sure everything is functioning properly before inspecting data packets. If everything is fine up to this point, you now follow the same procedures for wired networks. Now, here's always a question that comes up. Promiscuous versus monitor mode. Promiscuous mode enables a NIC and a driver to capture traffic that is addressed to other devices on the network, not just the local hardware address. In promiscuous mode only, without monitor mode, an 802.11 adapter only captures packet of the SSID the adapter has joined. Any packets on other SSIDs are not forwarded to the host. Monitor mode, on the other hand, captures all traffic with the adapter and driver passing all packets from any SSIDs from the selected channel to Wireshark. So just because you have a laptop set on monitor mode to channel 1 doesn't mean it will automatically capture every single SSID that's around you from all your neighbors. You have to capture at the specific channel. So again, you want to verify that your NIC is able to handle Wireshark and the things it can do before you run it. For example, is it recognized by Wireshark? What happens when you attempt to capture it? And when you capture, what do you get? If you're only getting data packets, then that means the NIC or the driver isn't passing control and management packets to Wireshark. So you'll end up with a limited vision. Wireshark is awesome in that there are more ways to capture information. For example, you can capture at 2 locations. If you're doing that, you'll use other tools like tcap, dumpcap, and Wireshark, all synced with NTP, with Network Time Protocol. You can use edit cap to alter timestamps so that everything syncs up together. You use merge cap to bring those trace files together. Any capture or display filters can help you narrow down your search. You can also capture simultaneously on multiple adapters. You could do remote capture as well. For example, with a switch, or using VNC or LogMeIn, or other ways of remote connecting to a device. There is a capture daemon that you could use that'll send packet captures to a Wireshark host. You'll need to add it into Wireshark, and then you'll be able to capture those. You can save packets to 1 or more files as needed. In order to capture a large amount of traffic, use a file set, and possible using ring buffers. File sets are contiguous files that are saved to disk. They can be individually opened and examined faster than individual files, especially large ones. In capture interfaces, you can specify criteria based on file size or time. A ring buffer limits the number of files saved and helps avoid filling a hard drive during an unintended capture session. For example, a ring buffer of 2 would save the last 2 files in the set, maintaining the sequential numbering scheme. So we can save packets based on time, the number of packets, the data. We can define when the next file will be made. We can do the same with a stop capture to say what will trigger Wireshark to stop capturing. We can do ring to limit the number of files saved. You want to have a computer who is optimized for Wireshark to avoid dropping packets. For example, You want to disable updating in real time, which is kind of hard for like Windows 10 where it wants to update. So you want to set a schedule to update so it doesn't download any updates during a capture, because you want your computer to be as silent as possible. Again, you want to disable network name resolution to help the computer stay as silent as possible to capture as much of the traffic. You can use capture file sets, which will make it easier to open the set later. And you can increase buffer size in the capture options. For display, as the packets show up, you can reduce the number of columns in the packet list pane so there's less for it to process. Again, by disabling things like coloring rules, we reduce the amount of CPU traffic needed to process all these packets that are coming in. And also disabling any unnecessary protocol tasks until we're done capturing, then we can do all these things at once. Of course, you can always use the command line since it takes away all the GUI, reducing the amount of work a computer has to do, like running Tshark or dumpcap or rawshark. Now for this week, there is the Module 1 assignment, where you'll open up two packet files, which again, they are available on CloudShark, so you don't have to download them. And you'll answer these two prompts. And then you'll run Wireshark on a host system for at least 5 minutes to see what you find. Kind of getting you to see what is happening on your network using Wireshark. You'll have a review quiz and 2 quizzes for this module. Again, if you get stuck at any point, please feel free to ask away on Discord. This class is not meant to be done on your own. It is encouraged for you to work with your classmates on solving all these quizzes. It's not cheating. The security world works together, and I encourage that in all of my classes. So once again, if you have any questions, please feel free to ask away on Discord. Myself and my TAs are there all the time. Cool. Hope you guys have a great evening. And